Hello everyone and greetings. A lot of people have been asking me to make a video about how I create custom INAV targets with Servo Support. This is a rather technical video and might not be something for everyone. Just as a disclaimer, I will not be providing support for this here. I will put a full transcript in the video description so that you can copy paste as well. This method might not work on all all-in-one flight controllers or stacks, since it has to do with the board design and layout. Every all-in-one flight controller or stack is different and using different definitions. The first thing that we require is an all-in-one flight controller or stack which already has an INAV target, and this is important. Creating a new one is a completely different topic. In this example, we are using a JAE MCU Pro all-in-one flight controller. This is a great and affordable I/O, but slightly outdated since it has an USB micro plug, and the HDVTX plug is actually made for the Vista. So if you plan to connect an 04, this has a different pinout, so be careful and you might need to swap cables. The first thing that we have to figure out is what kind of configuration we're looking for. In this example here, I want to have 2 servos, 2 motors. I want to have an 04 VTX, an ELRS receiver, and GPS. I have to look at the wiring diagram and write down which pads, respectively UARTs, will already be used for receiver, HDVTX, and so on. First focus on the receiver, VTX, and GPS if required. The next topic is to understand how to clone and compile the INAV target. This is documented on GitHub, on the INAV repository. You might as well need to install Git separately. In my case, I will be using OS X. When you have installed the requirements and cloned the INAV repo, go to Source Main Target. This is the location where all the possible build targets are defined. In this example is a JEF 405 Pro, which contains a target C and target H file. Open the target H file and locate the definition of UART2 and UART3, which are currently unused. The chip in this example is an F405, so we have to Google for the F405 CPU datasheet. Search for the resources to check if they provide a suitable alternate function. Now this is really important. The resources need to provide a timer and channel as alternate function and are not already used somewhere else, especially motors, as this could burn your servos. PD6 and PD5 don't have any timers on channels. PB11 and PB10, however, have timer 2 channel 4 and timer 2 channel 3 as alternate functions, and when looking at the target C files, these are used by motors M3 and M4, so we will disable them later. Now that we have figured that out, comment out UART3 in target.h. Since we have removed one UART, we as well need to reduce or adjust the serial port count and reduce it by 1. The next thing we have to look at is maximum PWM ports. I will disable 2 motor outputs later on since we can't use shared timers, but I will be adding 2 PWM outputs for the servos, so it still will be 4. Save the changes and open target.c. Now we comment out M3 and M4 since they will clash with the timers that we want to use for servos. Then we add the following below as definitions for the servos. You'll see here as well that we use PB10 and PB11. And I also comment to which UART this refers to, in this case UART3. And then save the file. As a next step, we will have to compile the target. On OS X, this looks like this. You open the terminal and switch to the INAV directory, create the build directory, change to the build directory, and execute cmake. And then we are executing make, and this is exactly the name of the folder where we had edited the files, and this will create the firmware target. The hex file will be then available in your build directory. Just as a side note, if you are not using GPS, UART4, respectively PA1 and PO0, these resources would provide timer 5 channel 1 and timer 5 channel 2, so they could as well work for server outputs, but keep in mind that we would need to adjust the maximum PWM outputs again. Now we can finally flash the custom target using the INAV configurator and pointing it to the local file we have just created. And then connect everything correctly and solder the servo signal wires to RX3 TX3. For power and ground, you can use any 3 pads which provide 5 volt and ground. You can as well share or respectively power 2 servos from 1 pad and also use a shared ground pad. If you now power up your flight controller, the servos should center and react to input. If this doesn't work, you either made a mistake or the target or all-in-one flight controller you're using is not suitable for that method. Good luck!